going through some more product rule questions, or we're going to again use product rule to differentiate a function, and then apply that to find, horizontal tangents and things like that. So we're going to start off with this first question here. I'm going to differentiate this function, y is equal to x squared minus 10 to the power of 3, and then times up by x to the power of 4. So you can clearly see that we've got two parts to this function that we're going to separate and differentiate using the product rule. So we obviously got this as our first part, which we can label as u, and this is our second part, which we'll label as v, and then use the product rule to differentiate these. Okay, so I'm just going to write that down here. So we've got y is equal to x squared, student out of it, minus 10 to the power of 3, and we'll multiply that by x to the power of 4. So again, we're going to say let u equal x squared minus 10 to the power of 3, and let's let v equal x to the power of 4. Okay, so to differentiate this, the derivative of u is going to equal to, so we're going to put the power down, 3, and then keep this bracket the same and reduce the power by 1. Then we're going to multiply this by the derivative of what's inside, which is 2x. And simplifying that, 3 times 2x, we can put that together, so that becomes 6x. And then we get 6x, x squared minus 10 to the power of 2. Okay, and so if this is our v is x to the power of 4, so the derivative of that is just going to equal to 4x to the power of 3. Okay, so now differentiating this, we can put it together. We've got dy over dx is equal to, we'll say u dash v, which is 6x, and then x squared minus 10 squared times x to the power of 4 plus v dash u, which is 4x cubed times x squared minus 10 to the power of 3. Okay, now we can do a bit of simplifying here. We've got 6x to the power of 5, x squared minus 10 squared plus, this we can't simplify it in here, so that just stays the same, squared minus 10 to the power of 3. Okay, now taking out the like terms, we've got, in terms of numbers 6 and 4, the common factor between 6 and 4 would be 2. And we've got x to the power of 5 and x to the power of 3. So we can take out x to the power of 3 here. And then we've also got x squared minus 10 as a common factor. X squared minus 10 to the power of 2. Okay. Then inside left over, we would have 3x squared plus 2 bracket x squared minus 10. Which again, we then simplify some more. So this is equal to 2x squared, and then x squared minus 10 bracket squared, and then we've got 3x squared plus 2x squared, which becomes 5x squared, and then we've got minus 1. So I'll just write that as a knowledge bracket now. Okay, so that's our final derivative. Okay, so a bit more steps involved in this one, just in terms of simplifying, but we've got our final derivative. Now, the question was actually asking us to find the point on the curve where the tangent is horizontal. And by now we should know that when it's asking us to find a point in a curve where the tangent is horizontal, that means you want to find when is dy over dx equal to 0. Okay? So if you want dy over dx to be equal to 0, that means that either, so if dy over dx is equal to 0, we have 3 options, right? Either 2x squared is equal to 0, or x squared minus 10 squared is equal to 0, or 5x squared minus 20 is equal to 0. Okay? So now we have to go through each of these, because since these are all multiplications, we know that if you multiply anything by 0, the answer is going to be 0, right? So if this is 0, doesn't matter what the value of these two are, the answer is going to be 0. If this part is equal to 0, doesn't matter what these two are, the answer will be 0. And same with this one as well. So that means that each of these times, if we get an x value that makes any of these terms equal to 0, then our gradient is going to be 0, and therefore our tangent will be horizontal. Okay, so for 2x squared to be equal to 0, that one's simple. For 2x squared to be equal to 0, that just means that x is equal to 0. X has to equal 0 for this to be true. Okay, but this one, if you want x squared minus 10 to how 2 is equal to 0, that means we want x squared should equal to 10, which means that x has to equal to plus minus root 10. Okay? Or we have 5x squared has to equal to 20, which means that x squared has to equal to 4, which means that x has to equal to plus minus root 4, which is 2. So these are each of the x values at which our tangent is going to be horizontal. And to find the final points in the curve, you would have to sub in each of these values back into your original y function to figure out the y value for each of these coordinates. Okay? So that's part A done. I'll just say that's question 1 done. And I'll just label that as part B so we know what we're referring to. And now let's go through question 2. So I'll do question 2 over here on this side. And again, we want to differentiate this function where we've got two products, and then we want to set the values of x for which the derivative is 0. So y is equal to 2x minus 3 to the power of 4 multiplied by 2x plus 3 to the power of 5. Okay, so again, this is going to be our u, and this is going to be our v. So we're going to go ahead and differentiate each of these, and then put them together to calculate the product rule, right? So our u is equal to 2x minus 3 to the power of 4. And it looks like a 4, so that means our derivative of u is going to equal to 4. We bring the power down, reduce the power of this expression by 1, and then multiply that by the derivative of whatever's inside, which is just true. Okay, so this just becomes 8 times 2x minus 3 cubed. Okay, now our v, it's going to be something similar. So our v is 2x plus 3 to the power of 5. So the derivative of v is going to be with 5, we bring the power down. 2x plus 3, we reduce the power by 1, or multiply that by the derivative of what's inside, which is just true. And simplifying that just gets us 10 bracket 2x plus 3 power of 4. Okay, so now we have these. Now we can put this together and find our derivative, dy over dx. So we're going to do u dash v, which is 8 2x minus 3 power of 3 times 2x plus 3 to the power of 5. And we're going to do the derivative of v times u. That's going to be plus 10 times 2x plus 3 to the power of 4 multiplied by 2x minus 3 to the power of 4. Now, again, we're going to simplify this, well, factorize it rather. And to do that, we're going to look at the numbers. So highest factor between 8 and 10 will be 2. So we'll take out the common factor of 2. Then highest factor of 2x minus 3 is 2x minus 3 to the power of 3. So we take out that. And highest power of 2x plus 3 is 4. So we take out that. Plus 2 to the power of 4. Now, what have you got left inside? So from this part, this first part, we've got 4 And then we've got times 2x plus 3 plus 5. And then we've got 2x minus 3. Okay, now we'll simplify this. So we've got 2 bracket 2x minus 3 to the power of 3 bracket 2x plus 3 to the power of 4 bracket 4. So we've got 4 times 2x, which is 8x plus 10x. So that becomes 18x. Okay, and then we've got 12 minus 15, which becomes minus 30. And that becomes our final derivative. Usually you can see with these complex ones, they usually end up getting, sort of three products multiplied by each other, and maybe a coefficient at the beginning. So you can see we've got the 3 products here multiplied by each other, and we've got a coefficient at the start. Similar thing here, we had 3 products, or 3 expressions multiplied by each other. So again, we have to do the same thing here. We want to find the values of x for which the derivative is 0. So again, if dy over dx is equal to 0, if dy over dx is equal to 0, that means that either 2x minus 3 has to equal to 0, or 2x plus 3 is equal to 0, or 18x minus 3 is equal to 0. Okay? So if 2x minus 3 is equal to 0, that means that 2x is equal to 3, and x is equal to 3 over 2. So that's one value where our derivative will be 0. Or 2x equals minus 3, and x is equal to negative 3 over 2. So that's another value where our x will be equal to 0. Or our 18x is equal to 3, and our x is going to be equal to 3 over 18, which is 1 over 6. So these are the 3 values. These are the 3 x values for which our derivative will be 0. Where k are the gradient of this curve of these 3 x values will be horizontal, or will be 0.